Okay, for anyone watching the recording, we just did the first slide already, but doesn't matter. Okay, so privilege escalation, the idea is you already have access to a system, but you want to get access to even more stuff. So an example of a scenario where you might want to do this would be if you, on the Rutgers iLabs, because anyone, any like CS major can get an account on the Rutgers iLabs, but you only have access to your one account, which this sort of situation isn't all that common today, which is why like this is pretty much the only example I could think of, because usually like everyone owns their own computer and you have access to do whatever you want on your own computer. So like this isn't relevant if you're talking about like your own laptop or desktop or something. But usually this would be like with shared computer systems where multiple people have access to it, so they don't want to give everyone access to everyone else's files. Um, so this would be a situation where if you were looking to like hack someone else on the Rutgers iLabs, you'd want to try and get like privilege escalation to increase your privileges so that you can see other people's stuff. I think it goes without saying, but like don't actually do this.
If I do, can I blame you?
No, because I told you not to.
No, you said example Rutgers iLab.
Yeah, but I said I have a disclaimer, so I'm good.
I'm too far away to see.
What?
I'm too far away to see that.
Well, you should have sat closer. That's your fault.
We should just rename privilege escalation to vertical movement.
Yeah.
We already have lateral.
All right. So sudo is a command used on Linux and other Unix-like operating systems to run commands as a different user. And most commonly, it's the root user, which is why it's called sudo. It's short for super user do. But sudo actually has a very extensive permission system that isn't commonly used. So you can allow a specific user to run a specific command as another specific user. So like you could allow, for example, one user to run just one command, and instead of running it as the root user, you allow them to just run it as like a different person. And this permission system is not very frequently used. I'll sort of get into why that is in a couple slides. Yep.
Could you like, I guess, edit them in the same style like you would do with group policy in a Windows machine? Kind of like on different like Linux machines, super users have different permissions.
Yeah, I mean this would be per machine.
Oh, okay. Well, it's kind of like the same as a group policy.
Yeah, it's kind of similar idea. Yeah. Wait 1 second, I'll be right back.
In the meantime, I'm hacking the iLabs.
What?
In the meantime, I'm privileged escalating the iLabs and blaming you.
All right. Okay. Another important concept is a feature called setUID on Linux. So this is a flag which executables can have, and what this says is that any user can run this program as the root user. It's not actually necessarily the root user. It can be any user, so it's technically the owner of that file. So you could also just have it allow any user to run some program as a different user, but it's almost always going to be the root user. So this is actually how sudo works. So sudo is a setUID program, and so running sudo runs it as the root user. And then while running as the root user, sudo checks your permissions. And if that permission check fails, or if the password check fails, then it just exits the program without running your command. Okay. Also, I can just demo on my own computer some of these things. What? What do you mean?
Which job isn't this me?
Oh no, this is Manjaro. Okay, should I zoom in a little? Okay, that's probably good. So if you want to see, so let's use less. If you want to see the users on your system, you can look at the etc password file. This doesn't actually contain your passwords. It's just called that for historical reasons, because in like very old versions of Unix, it used to contain your passwords. But the issue with putting passwords in here is that because this contains all of the other user information, it has to be readable by everyone. So like even if your passwords are encrypted, or hashed, it's still like an unnecessary risk to have them readable by everyone. So that's in a separate file on modern systems. But you can see like there's a huge list of users, and they're almost all system users. So there's like, I don't know, 100 system users or something. And then somewhere in the middle here, there's my actual user. This is the only like regular user on the entire thing. All of these other ones are system users. And these are all just for like random services. So there's one for QEMU, one for libvirt QEMU, which is obviously a separate thing. Systemd journal upload, Tor, GVM, yeah, DHCP, postfix, Postgres, Redis, named Snort. I didn't even know I had Snort installed. NM OpenVPN, NM OpenConnect, LightDM, Git, GeoClue. I don't even know what this is or why I haven't installed.
Geoinformation service.
Oh, okay, wait, I know what this is. It's for the what's it called? Blue light filter program that I use requires this because it does some fancy stuff where it figures out your nighttime hours based on like where you're physically located.
You can't just check the system clock.
I don't know, but I can't. Yeah, I can't disable this. I tried to disable this because I don't want it to be there, but like I couldn't figure out how, so I just gave up.
So are you dual booting between Manjaro and Windows then?
Yeah.
That's cool.
Yeah, and then there's like actually a ton of systemd ones.
We're done.
But yeah, the point is like almost all of the users on here are just like random stuff that isn't an actual user. It's a system user that's like specifically there to run system processes in the background. And there's also this one called Nobody, which is a sort of historical thing. So like back a long time ago, before the concept of system users as we have it today really existed, Nobody was just like the system user. It was the user that like every service used. But obviously that sort of defeats the point of having it because now like this one account has access to every single service. Like you're not really implementing principle of least access anymore.
So if I'm reading that right, then all these have the same execution privileges, right?
What do you mean?
Because well, that's what the X stands for. That's the read, write, or execute permissions now.
I think that stands for something else here. I don't think it's read, write, execute, but I don't know exactly what it is. Oh, I think that's where the password would normally go, and the X means it's not here.
Okay.
So the X means it's in the other file, which is etc. shadow, and you'll see if I try to read it, it tells me permission denied because normal users aren't allowed to access that one. Yeah, and then the other things. So for sudo, there's a command vi sudo. And you have to run that as sudo, of course.
Is it double exclamation mark the previous command?
Yeah.
Oh wow.
Yeah, this file must be edited with the vi sudo command as root. Failure to use vi sudo may result in syntax or file permission errors to prevent sudo from running. So yeah, there's some files like this where like this file is so important that you're not allowed to just edit it manually. You have to use a special command, and then that command will like verify your syntax. So like you don't completely break your system by messing up the file. So there's like a bunch of stuff that's commented out here that's like not really important. I think the only uncommented thing are okay. I think this is actually the only uncommented thing. Read drop-in files from this directory. Oh yeah, and also here root. This is technically unnecessary, but I think it's just like this is technically unnecessary because root already has permission to do anything. But like sometimes when you're copying and pasting commands, you'll just copy and paste a command that has sudo in it. So it's just helpful if like root can do anything as sudo, even though like root can do anything without sudo to begin with. So you can look at etc. sudo is d. And are there any files in here? No, there are not. So did I miss something?
This shell looks so much cooler than mine.
Okay, it doesn't have my username in here anywhere. So usually there's like a group called either sudo or real, or I think there's like a third thing that it could be called, and that's what gives users permission to run commands as sudo. But in this one, both the wheel group and the sudo group are commented out, so I don't actually know what's giving me sudo permissions. One thing you can actually do to check that is if you run ID, they'll give you a list of every group you're part of. So here it shows my user ID, and then this group ID is what's called your primary group, and that's on almost all systems just going to be a group with the same name as your user. And then this is a list of all groups I'm part of. Okay, yeah, so on my computer it is wheel, but yeah, for some reason it's like commented out, so I don't know how that works. Okay, yeah, so and the last thing is we can look at the permissions of the sudo command too. So if we do which sudo, that tells us the actual file that's being run whenever we run sudo. And then we can do ls-l user bin sudo. And you can see these are the permission bits. So this first triple is the permissions for the owner of the file, which in this case is root. So normally that would be R for read, W for write, and X for execute. But since it says S for execute here, that means that it has setUID enabled. So that basically means that in addition to root being able to execute it, anyone else who has permission to execute it will be able to execute it as root. And then this R-X here means that other users, so technically this first R-X is the group permissions, but the group is also root here, so that doesn't really mean anything. And then the other user permissions are R-X, which basically means the dash means that write is disabled, and then R is enabled and X is enabled. So you're allowed to execute it, and then the S here means that anyone who executes it as root.
Is December 16th when the file was created?
I think that's the last time it was modified. So that's probably like the last time there was an update to sudo that I installed. You can also, we can actually see that in more detail if you use the stat command that gives us access, modify, change, birth. Yeah. And also worth mentioning, on most Linux systems, access times are disabled because like they make file system accesses really slow because every single access has to update that time. So you'll notice is like basically exactly the same thing as the change time. And I think birth also like isn't implemented on a lot of Linux file systems, so that's also the same as change here.
Oh, it's weird because birth comes after. So either that's not birth or the first one is. Because December 16th is before the 23rd.
Yeah, that's what I mean. Like birth isn't.
Okay.
It's not accurate because like most Linux file systems don't implement it.
That's cool.
And then I think modify is the last time the actual contents of the file are changed, and change.
Oh yeah, it's the same date though.
No, it's, modify is the only one that's different
Yeah,
because it's the 16th instead of the 23rd. Oh yeah, it's the same as this. Oh yeah, I think that's everything I wanted to demo. So now we can go back to the slideshow. Any questions about that so far? We also just check Zoom. Okay, no one in Zoom still. So basically actually using these sort of advanced configuration things either to allow like advanced pseudo stuff or set UID for commands is actually really risky. That's because a lot of commands allow you to do some very unpredictable things. So there's this cool website called GTFO bins, and it basically has a list of like every common Linux program. So like all of the ones that are usually built in, plus a lot of ones that are like really common to have installed. And it has a list for each of those programs of ways you can make it do like unpredictable stuff. So for example, you can get a shell, edit files, more of that kind of stuff. So the idea is if you can run one of these commands as root, then you can do all of those things as root. So that's why, for example, it's dangerous to just say that like you can run a certain command as sudo, because even if like this command seems harmless, it's like there's probably some special option that you can use to like run arbitrary commands using this command. So you can look at this website. It's pretty cool. So this project contains legitimate functions of Unix binaries that can be abused to get the fuck out or break out of restricted shells, escalate or maintain elevated privileges, transfer files, and so on. And you can see there's like pretty much any command you can think of. So like, just come up with like your favorite Linux command. Just pick a random one.
Systemctl.
All right. Well, systemctl is like probably going to be one of the more dangerous ones, but yeah. So
Okay. New favorite one is more.
what?
More.
Okay, more I know for sure has a thing. It's probably one of the ones you wouldn't guess. So, so yeah, you can use it to break out from restricted environments by spawning an interactive system shell.
Rep.
Yeah, let's just read all of this first. Okay. So, I thought it was going to be something different, but like I guess this is how you would do it if you wanted to make if you wanted to use your access to having more to like get into an interactive shell. And set UID. Oh yeah, file read. I think that's pretty straightforward. That's like what you're supposed to use more for, because more is like literally just a command for reading files. Yeah, and then sudo is just the same thing. SUID. If the binary has a SUID, it does not. It is used to run sh.p. Omit the p. Okay, this example creates a local S. Okay, yeah. So now we can look at, what did you say, grep, right?
Yeah.
Okay. So file read, I would not have guessed.
Is there anything that's like not gonna be here?
If you look hard enough, you can probably find one. So if the binary has the SUID bit set, it does not draw. Okay. Huh. Oh, this is interesting. It doesn't actually seem to say anything about like using this to run commands, unless I'm missing something. It's both of these are just using this to read a file. Like these are all the same thing. Yeah, not sure what's up with that, but okay, so I guess grep doesn't actually have a way to run arbitrary commands. We can try like other stuff, like tar is an interesting one. Because tar is used normally to like compress and decompress stuff, but there are actually a bunch of ways you can use it to start a shell. So there's this checkpoint action thing, which lets you exec any command. There's this -i thing, which also lets you exec any command. And then there's this --2 command thing, which also lets you exec any command. Yeah, and then apparently tar also lets you exfiltrate files over a network. So tar apparently has built-in support for SSH, so you can just use SCP syntax with tar. Oh yeah, and you can even just change the RSH command, so it just skips using SSH. Oh no, here it's setting it to SSH. Okay, but you could, in theory, just set this to something else and use that to run another command too. And then file download, I guess the same thing. And then file read and write are kind of obvious because it's like a command that's used to read and write files. Yeah. Any other things to look up?
I mean, we saw more. I'm assuming less is going to be here. Maybe.
Yeah, less is definitely here, and less I think has like a much easier way to execute stuff. So, Okay, yeah, so less you can just like set the visual variable, which what is it? Visual is supposed to control like how you edit. I think it's like unless you can press V to like open the visual editor, and the doing something else like in SH will make it run that instead. And then yeah, there's also exclamation mark and less. So I can actually just demonstrate these right now. So oh yeah, I still have my terminal open. So if I do like less, let's say pass. All you need to do is if you put an exclamation mark, you can actually run any command. So I can just do exclamation mark bash, and now I have a bash shell. Since I was already running bash, you can't actually tell the difference, but this is actually a separate bash shell. So actually, I guess to make it clear, so you know when I exit it, it like exits this. If I run sudo, then when I run bash like this, now I have a sudo shell. And then you can also press V, and that puts you into, I think this is Vim. And then from Vim, you can also do the same thing. So colon, exclamation mark, and then any command. I think you can also just do shell from here. Yeah. There's like a lot of stuff you can do with less. Obviously, I also just showed off you can do the same thing with Vim basically too. And then file write is like also one that you wouldn't expect because less is usually used for reading files, right? But you can also just use it by, I guess, these techniques, but also just like pressing V to open Vim. Yeah, and the rest is basically the same thing. Any other ideas?
Echo.
Echo. I'm not confident about this one, but yeah, okay. Exit. I think echo and exit.
Oh, exif though I saw. Hold on.
Yeah, exif
What?
tool. Let's see. So file write.
That's not what I would have imagined.
Sudo can. Okay, so some of these with sudo are just like you can use this along with the file read or file write, which I guess is like not very useful. What?
Kind of like in the same way that Les was doing it.
Not in the same way as less, because less you could actually use sudo to get a shell, but this one it's like you can just use sudo to read and write files as root. So it doesn't look like you can actually use this to get a shell, but the file write thing is pretty interesting.
ETF opens.
Yeah.
What's the pattern on this?
Any other ideas? You can also just scroll down and look through these.
Wait, did it say Docker?
There's base 64. Let's see, does this let you do anything interesting? Yeah, no, none of these are very interesting. They're just file read.
Go to AWS.
AWS. Huh. Oh yeah, because this just starts most likely less. Unless you're on like a really old system that has it set to more. So yeah, there's some commands that have stuff like this where it's like there's some subcommand that will start like a different command like less that will let you like do whatever that allows.
Docker is on here too.
Yeah.
Emacs.
Yeah. Well, Emacs makes sense. Emacs lets you do like literally anything.
Yeah.
Let's see what Docker lets you do. Oh yeah, you can just like run a container that allows a Docker escape.
Wait, man is here?
Oh yeah, because man uses less as the backend by default. So you can just do whatever you did with less, and it'll do the same thing.
Okay, S2012, so Nano is here too.
Yeah.
And Nano.
Yeah, Nmap has the whole script thing, right? So you can just use Nmap to run any script as root. So yeah, okay, we looked through this for a while. We can keep looking. There's like a few hundred things here. What did I just click on? SMB client. Makes sense. I don't know what happened.
Love your profile pic on Chrome.
Thanks. My mouse stopped working. I don't know what happened.
Need another one?
I don't know. Oh, okay. Okay, I figured it out. Apparently, if I accidentally hit FN F11 on my computer, there's like a special function key that disables my trackpad. I don't know why that would ever be useful, but it's there. Yeah, so the last part are exploits. So what we've gone over so far, like things that you could misconfigure to allow people to run stuff as root. So, oh yeah, one other thing I wanted to demo, I forgot about this earlier, is you can do, if you want to check what you're allowed to run as root, you can do sudo -l. This makes me enter my password. Yeah, and this tells you what command you're allowed to run. So for me, it's all because this is like my own computer, so I'm allowed to do everything as root. But like on other computers, this might tell you like, hey, you're allowed to run this one specific command as root. And what you'd usually do if you wanted to prevesc on that system is like you'd look up that command on GTF opens and see if there's anything cool you can do with it.
On the iLabs.
Hypothetically, don't actually do that. In the hypothetical scenario that you wanted to prevesc on the iLabs, but you shouldn't do that because that's like illegal and stuff. Yeah. And then for set UID, there you can use the find command. Like you can just look this up, but yeah, there's a flag. It's like -perm 4000. This checks for files that have the set UID pit set. So that's because these three on the right are like the regular read write execute bits, and then this one over here is like this fourth number over here is the extra bits. So this is like set UID. There's also set GID, which is like the same thing as set UID but for group ID. And the last one is sticky, which is like a special thing that's used for like temp and some other directories. Yeah, so you'd use something similar to this if you wanted to find like what commands on your system have set UID permissions. And so there's what we've looked at so far, like misconfigurations that would allow you to run stuff as root if something has been set up improperly. But there's also from time to time exploits that are discovered where there's like a bug in either the Linux kernel or in some program that's used on pretty much every Linux system, like sudo, that will let you run stuff as root, even if there's like nothing wrong with. There's like nothing that the system administrator could have done differently to like prevent this. So, yep.
But with the misconfigurations, because that just popped in my mind. So like, is the solution to that just to limit permissions? Because a lot of these stuff is just like everyday stuff that users use, like Nano, Emacs.
Yeah. So the point is like, if you're just running less normally, it doesn't make a difference if you're able to run bash from that because it's like I could just run bash myself.
Yeah.
But the point is, like, if you're allowing users to run like some commands as sudo, like you might think like if I'm allowing
run it, but not as it does not use sudo.
Yeah, so like
Okay.
so for example, one thing you might see is like there's some file that we want some users to be able to read, but it's only accessible by root. So instead of just changing the permissions on that file, we'll like allow people to use less on that file. And then it's like one
root version of it then.
Yeah, and then like once you're allowed to use less on that file, you can just do like exclamation mark and run any command you want.
Okay.
And then it runs as root. So it's like stuff like that where pretty much I think like the majority of commands on Linux have some way to do stuff that like you wouldn't guess you would be able to do.
Right. Okay. That's cool.
So it's mostly just like you have to be very, very, very careful if you ever use like the advanced sort of permissions in the sudoers file. Yeah. So anyway, for exploits, let me also just check Zoom. Is anyone here? Nope. Wait, what's my battery at? 28%. Okay, we're good. The exploits are usually patched pretty quickly, like within a few days. But some people just like don't update their systems. Some people like just don't feel like updating and are using a system from like 2011 or something that has not received an update in 5 years. Yeah. Yeah, I may or may not have used systems or records like that. So here's a list of some common ones. So these are two slightly older ones. There's Dirty Cow, which is, you can look at that. This is one from 2016 that I think like most people are probably using something at least that has had a security patch since 2016. But like this is a bug that lets you get root. And it's a bug in the Linux kernel, so it affects like literally every Linux distribution, regardless of like what other stuff you have installed. And then there's Dirty Pipe, which is similar to Dirty Cow, and it was fixed in all of these updates. And yeah, there's more technical explanations, but the important thing is like these vulnerabilities let you get root on stuff. And then there's also this one. I don't think the vulnerability itself has a name here, but there's this tool for it called PwnKit, and this is a really easy thing to use. So a lot of people just call this exploit itself like PwnKit. And yeah, this is basically something that like you can just run it on a box, and sometimes it'll give you root. Yeah, these last two are pretty recent, 2021 and 2022. So it's like within the last few years. So like if someone hasn't updated their machine in a few years, they might be vulnerable to this. And also like on Hack the Box, if you're interested in doing that, you can sort of skip doing the intended solution for a lot of their boxes because they're vulnerable to one of these and they haven't updated it. Because like if the box is a few years old and they haven't updated it,
the retired ones too, they probably don't update.
Yeah, especially the retired ones.
So I can just curl that command and I get root access.
Yeah, kind of.
Cheat through the leaderboard though.
Yeah. Yeah, and that's basically it for today.
Can you still post these? Because I want to like look back at some of this stuff.
Yeah, I'm gonna get through the backlog like this weekend.
Oh, there's a okay.
There's a very long backlog. I haven't posted anything in a long time.
Where is everybody though?
I don't know.
I think this is a more convenient time for workshops than last time.
Yeah.